Hi guys, it's Mrs. Harmison, and this is Physical Science video notes for Section 5E. An atom is made up of three different types of subatomic particles. In the nucleus, we have protons with a positive charge, and we have neutrons. Those have a neutral charge. The subatomic particle that we are going to be especially concerned about today, however, is the electron. Electrons are really important in bonding, especially these ones, which are called the valence electrons, which means that they are in the outermost shell. So protons are positive, electrons are negative, and the electrons, these valence electrons, the ones in the outer shell, are the ones that determine how an atom bonds. The elements in this first column are going to have one valence electron, which is the 3A group that starts with boron. All of those elements are going to have three valence electrons. Carbon and the others in its group are going to have four. Nitrogen, phosphorus, and that group, they're going to have five. Oxygen and all of those below it are going to have six. Fluorine are seven. And then these guys over here, the noble gases, are going to have 8 valence electrons. How many valence electrons does each atom want? The answer to that question is 8. Each atom would like to have 8 valence electrons. That is what is called a full octet. And when an atom has a full octet, that is when it is the most stable. And atoms are trying to get to be stable. There are exceptions, just like there usually are in chemistry. The two main exceptions are that hydrogen and helium, they both only want to have 2 valence electrons. They can't hold 8 valence electrons. So their first shell holds 2, and if it's full, then they are stable. So let's look at the example of calcium. You can see here that calcium is in this group, so it's going to have 2 valence electrons. So 2 valence electrons for calcium. So calcium has 1, 2 valence electrons in its outer shell. And how many did we say that it wanted? We said that it wants to have 8. So to get 8 valence electrons, calcium can either gain 6 electrons, or it can lose the 2 that it has and go down to its next energy level. So what atoms are going to do is they're going to do what takes the least amount of energy. And it's going to take much less energy to lose 2 electrons. So they're not going to spend all the energy that it would take to gain 6. This atom, calcium, would lose 2 electrons. So for this sentence, we say calcium would lose 2 electrons. And then it's going to form an ion. So the ion is going to start with the symbol for the element, which is calcium. And we need to figure out what charge it's going to have. So because an electron is negative, this is going to seem kind of opposite. But if it loses an electron, any atom that loses an electron is going to get more positive charge because the negative is going away. So in this case, calcium is losing 2 electrons, so it's going to end up with a positive 2 charge. So Ca plus 2 is the ion that calcium would form. In the second example, we're going to look at phosphorus. Phosphorus is right here in group 5, so it's going to start with 5 valence electrons. A common way to draw electrons around an atom is by making dots. So phosphorus has 1, 2, 3, 4, 5 valence electrons, and it would like to have 8. So in order to get 8, it could either lose 5 or it could gain 3. This is going to take more energy, so it is not going to lose 5 electrons, it's going to gain 3 and end up with a full octet. Phosphorus would gain 3 electrons and form the ion P for phosphorus, and then we put the charge in, and since each electron is negative and it gains 3 of them, it's going to end up having a charge of -3. Another thing that the periodic table can tell us that is helpful when we are trying to figure out what kind of bonding is happening is whether an element is a metal or a non-metal. So as you can see, I have this stair-step line on the periodic table. All of the elements that are above this stair-step line are non-metals. And then these elements down here that are below that stair-step line are metals. So metals go all the way over here and up to here and over to here. And then these ones are the non-metals. Hydrogen is an exception. So it's over here on the left, but it's not a metal. So it goes with the non-metals. Here are some important facts about ionic bonds. Ionic bonds are formed between a metal and a non-metal. In an ionic bond, electrons are transferred. In an ionic bond, the metal loses electrons and becomes a positively charged ion. The nonmetal gains electrons and becomes a negatively charged ion. The two atoms are then held together by opposite charges. So let's look at this example of an ionic compound. First, let's look at sodium. Sodium is in this first column, so it's going to have one valence electron. And then the chloride here represents chlorine. Chlorine is over here in this column, so it's going to have 7 valence electrons. So we have sodium with 1 valence electron and chlorine with 7 valence electrons. And as a reminder, they both want to have 8 so that they can have a full octet. So sodium has 1. It would like to either lose that 1 or gain 7. It's much easier to lose this 1. So sodium is going to give away its electron. Since its electron is negative, sodium is going to become a +1 charge, and we just write that with a plus sign. Chlorine over here has 7 valence electrons and would like to have 8. So it's going to be good for chlorine to gain an electron. So chlorine gets 1 extra electron. Again, because that electron is negative, chlorine is going to have a negative charge. So sodium has a +1, chlorine has a -1, and what's going to happen is they are going to be held together by the opposite charges. Sodium's positive charge and chlorine's negative charge. And this is what is called an ionic bond. And then a covalent bond. A covalent bond is formed between two nonmetals. In a covalent bond, the electrons are shared. And what happens is the two atoms are bonded together because they are both holding on to the same electrons. Here is an example of a covalent bond. It happens in hydrogen gas. The hydrogen is over here, and it has 1 valence electron. Each of these hydrogens is going to have 1 electron. Now, if you remember earlier, I told you that hydrogen is an exception. It doesn't want to have 8 because it can't. It would like to have 2 electrons to have a full shell. So this hydrogen wants to have 2. It would like to get 1 more. This hydrogen would also like to get 1 more. But neither one of these hydrogens wants to give away its electron. So instead of giving and taking in this case, they are going to share. So each hydrogen will share 1 electron with another, and this hydrogen feels like it's holding on to 2 electrons, and this hydrogen feels like it's holding on to 2 electrons, and so they're both stable. This is a single covalent bond between 2 hydrogens. In this case, they share the electrons, and they're held together because they're both holding on to the same electrons.